Hello everyone, my name is Amanda and welcome back to another video of the Plenty Mandy. Okay, so today we're going to talk about one of the biggest and most requested topic, which is lights, or how we as plant parents can use lights effectively to maximize our plant growth. And I'm going to divide these topics into two videos. The first video is today, we're going to talk about, more scientific foundation of how light works, or like how plants utilize lights. Some of the useful measurements units to measure light intensity, as well as some equations. Are you guys bored yet? And also we're going to talk about electrolytes. In the second part, which is, the next video, we're going to talk more about artificial light, right? So I separate that into two videos for multiple reasons. Number one, it's going to be super long otherwise. And the second reason is I do want to go deeper into, or just a little bit deeper into like, the basic science, because without knowing that, right, you won't be able to actually fine-tune or adjust, what I recommend you to do in the future if you find out that, that particular recommendation actually doesn't work for your environment, right? Remember, everyone's home environment is different. So let's say today I don't tell you anything behind, or I don't tell you the reason why I recommend this particular grow light, or I don't tell you why I recommend you to put this plant, at these directions of your house. Then in the future, if you find out, wait, it doesn't work for me, like what's going on, then you won't have the knowledge or capability to actually adjust and fine-tune it. So that's why it's always important for us to understand why, we are doing something for our plants. And that's why I decided to separate into two parts. And so, so that's basically what's going to happen. And the second thing I want to mention before I move on to the video is to, I'm sorry it took me so long to film this topic. I know that a lot of you guys have been asking since winter, but, it took me a while to do some research because it's just a really big topic. And I do want to make sure that I give you enough, give you accurate information that is unbiased. So I read a lot of books. I talked to some horticulturists. I read a lot of peer-reviewed journal. I have to, dig back into a lot of my MS stuff in grad school. So it took a while. So thank you for your patience. And the second thing too is because of the huge amount of information I got, I also want to distill those before I gave it all to you, because yes, you do need to know some basic science concept, but you don't need to know all of it. So that's why it took me a while to basically summarize and just took out what you will need to do, what you will need to know in terms of this topic. So yep, that's the disclaimers, and let's get started. Alright, so first of all, what is light? So light is basically the things that you see outside of your window, like from the sun, or the thing that you see from your kitchen light bulb, right, coming down. So you can, but more scientifically though, we can see light as beams of photons. And what are photons? So photons, you can imagine them as tiny light particles that compose the light beam that we see using our human eyes, right? So this photons, will shine down from the light source, whether the sun or the bulb or whatever, right? They're like, you can imagine them as wing drop. So they will, come down and then they will hit your leaf surface, right? And inside the plants, there is this tiny organelles, or like plant organs called chloroplast. And chloroplast is responsible to absorb these photons and then use that as a food source or energy source to conduct photosynthesis. Our favorite term, photosynthesis. So that would also drive the other essential like surviving functions of the plants as well. So that's basically what light is to plants. They are basically food. With that being said, without light, your plants will die, period. It's just like without food, if I don't give you food, you'll die eventually. So that's why light is so important for plants. Not only that light is food for plants, but they also determine other factors like of growth, like for the plants. So for example, how much light the plant is getting, it's actually determining how much water the plants will be able to use, and also how much nutrients, like the fertilizers that we give our plants, how much of those we'll be able to use, because without the light, without the photons, the plants won't be able to photosynthesize. If the plants are unable to photosynthesize, that means that they won't be able to use water or the fertilizer that you gave them, because those are the stuff that only will be used when photosynthesis happen. Does that make sense? Yeah, so that's why a lot of time we heard of like root rot, right? Or like, your succulent, you don't give it enough light, it eventually rots, right? It's because, it's because you don't give your plant enough light. So the photosynthesis is not happening, or like it's not happening enough for the plants to use up all those water and nutrients in the soil. And that's why the plant die. And that's how important light is to plants. Not only that, they're the food for plants, but they also determine like other uptake, like the water and the nutrients of plants. And that's basically the very basic foundations of light and the relation between plants and lights. All right, so let's talk about spectrum, light spectrum, right? So this is another term that we heard a lot, full spectrum or whatever, right? So when we talk about light spectrum, I'm going to introduce you to one interesting term. It's called PAR. So what does PAR stand for? PAR stands for photosynthetically active radiation. So essentially it's the white light beam that we see from the sun, it's actually composed of different wavelengths or different color of spectrum. So what is visible to our human eyes is from about 400 nanometers to 700 nanometers. There's the UV lights, and there's also infrared that are unable, with that as human, we are unable to see that with our own eyes, right? So the PAR, the photosynthetically active radiation spectrum, exists within the 400 to 700, about 400 to 700 nanometers. So that's basically what PAR is, right? So it is a very important concept to understand that plants do use all spectrum, right? All different colors. Yes, it is true that plants photosynthesize most efficiently with the blue and the red spectrum. And that's because the chlorophyll A and chlorophyll B, which is what the plants use to absorb photons and do photosynthesis, actually synthesize the most doing with the blue and the red spectrum, right? However, it doesn't mean that the plant don't use other spectrum. So I heard of this really interesting experiment from Chris Sech, which is a chief plant scientist from the SIL, which is a pretty famous plant shops, I guess, based in San Francisco, I think. And he said that he tried to grow basil plants, basil, the herbs, in his closet. And that there's no light in closet, right? So he decided to use a blue and red spectrum grow light in the closet in order to grow the basil, right? So he succeeded. Like he did, the basil did grow like leaves and all that, leaves and stems and all that, right? However, when he tear out a basil leaf and try to like expect that really like herby, basil-y smell, he smelled nothing. It just smelled like grass. It smelled like leaves, right? And later on, he found out that in order for basil to have that herby smell, the basil have to secrete certain kind of oil, and that oil will only be secreted with the yellow or orange, I forgot which one, light spectrum. So because he was growing the plants with only blue and red light wavelengths or spectrum, the basil wasn't able to produce the oil, and hence the basil doesn't have any smell. So that's one of the good examples to tell you that, our plant do use different light spectrum, right? And the other good example or like good observation is is, you know, the green light, right? So green light is the light that is most visible to our human eyes, right? And this green light is also the light that we reflect from the plants the most, because the plant, that's why the plants are green. And the reason that the plant reflect most of the green light back is because green lights are the least useful or least effective in terms of photosynthesis. However, the green light does play an important function, you know, to control the opening and the closing of the stoma, which is the pores on the leaves. So these are just a couple of examples to show you that plants do use all spectrum. But, you know, in terms of photosynthesis, the plants use the blue and the red wavelengths the most. So that's basically is a concept of PAR, you know, that we'll want to understand before we move on. All right, so now we understand light spectrum, right? Different colors of light, and we understand the concept of PAR, which is the visible wavelengths, you know, to our human's eye that plants can actually use to grow and to perform its essential functions. We're gonna move on to the light intensity. All right, so this is the more complicated topics. All right, so a lot of time I would get question, you know, people would ask, oh, like, it is, my plant is not growing, it's not, you know, it is because my light is not, you know, strong enough, or like, should I put my plant closer to the light, or, you know, what should I do, pretty much, right? So the answer is not that simple, right? Because when you look at the light intensity, you're looking at the total volume of light. You're not just looking at a single factors. So I would say, if you want to know how intense your light intensity, you would have to look at least 4 different factors. And these are the 4 factors that I distilled, and, you know, I believe those are the more important. Like, don't get me wrong, there's probably like plenty other, you know, factors, but these are the 4 that, you know, I can see that is the most important, right? So first of all, what is the total volume of light, right? What are the 4 factors? So you have to look at the light density, so how dense the light is, how concentrated those photons are within that light stream or light beam, right? And second, you have to look at photoperiod, which is the duration of how much photons your plant is actually receiving within a 24 hours period. Third is the distance, how far your light source is to your plant, right? And last but not least is the area, how big of an area you know, that your light source is, you know, providing all these photons, you know, for the numbers of plants within that area. So these are the 4 factors that, you know, or 4 variables that I have in this equation, right? So I'm going to go into each of these factors, you know, to explain to you like how we can understand them and how we can measure them to maximize our plant growth. First, we're going to talk about light density. So how concentrated those photons are within that particular light beam that you are providing for your plants. So there's different ways on the market that, you know, we can measure the light density. A lot of time we'll heard of terms like lumens or lux or foot candle. So those units actually measure the brightness of light to human eyes only. Essentially, it means nothing to the plant because human eyes see light very differently than plants. So, like I mentioned before, right, the blue and the red spectrum are the most effective for the plants to photosynthesize, right? However, the blue and the red lights, most of the time to a human eyes, are dim. However, the green light, right, like we said, the least effective for the plants to photosynthesize, you know, it's actually the brightest to human eyes. So I hope you see that what we see with our eyes in terms of the light, how bright the light is, it's completely useless for the plants. And that's why the lux or the lumen or the foot candle that we use, you know, even though it exists, it provides some kind of reference. It doesn't really translate, right? However, spoiler alert, in the next video, I will teach you how to convert those like rather useless units into more useful units, for, basically for what the plants see, right? But we'll leave that for next time. All right, so in order for us to accurately measure how dense, like how concentrated the photons are, for the plants, we have to look at something called PPFD, all right, and other acronym. So PPFD stands for photosynthetic photons flux density. All right, so essentially it's measure how many photons, right, in micromoles, right? It's raining down from the light source over 1 square meters of area per second. So basically PPFD, the unit of PPFD is umole per square meters per second. So in case you're curious, mole is a measuring unit for photons, and micromoles it's actually 1/1,000,000th of a mole. So basically it's very small, right? So one more time, PPFD, right? PPFD stands for photosynthetic photons flux density. It's measure how many photons in umole it's actually raining over your plants within a 1 square meters per second. All right, so yeah, so basically that's what it's measured. So in order for us to accurately understand how dense the light is for our plants, we have to use PPFD instead of, lux or foot candle or lumen, because PPFD actually means something to the plant, right? So how do we measure, PPFD, right? So remember we talked about like lux, foot candle, and lumen are rather, it's somewhat useless for the plants, but those can be measured pretty easily with something called light meter. So I don't have one here, but like I'll, put a picture. So light meter essentially you can get it from online for like 30-40 bucks. It's pretty affordable. So it's basically measured, if you put it to a light source, it will measure what are the lux or what are the foot candle or what are the lumen for the particular light source, how bright it is to human eyes, right? So you can do that. However, for PPFD, you'll have to use something called PAR meter. Remember PAR, right? Photosynthetic active radiation we talked about before. Basically that spectrum, 400 nanometers to 700 nanometer spectrum that human eyes can see. So you have to get a PAR meter. So PAR meter is at least 10 times more expensive than a light meter. So because it does measure, the actual photons in the light, and it actually means something to the plants, right? So that will be how you measure it. So if you are very serious about lights, you can get a PAR meter. It's a good investment, I would say. However, if you don't want to, or if you feel like it's out of your budget, like I said in the next video, I would give you some like math. So we'll be able to convert some of the foot candle or lumen or lux into PPFD. So yeah, stay tuned for that. So yeah, but basically I just want to introduce the concept of like how do we measure how dense the light is, which is one of the 4 factors to actually measure light intensity. So PPFD, we're measuring again how many photons in unit mole it's raining over 1 square meters of area per second. So the next factors we have to look at, in terms of measuring the total volume of light, aka the light intensity, is the duration, how long your plant is actually receiving light within a 24 hours period. So with this variable, we have to look at a concept called photoperiod. So photoperiod essentially is basically how long your plant is actually getting light versus how long your plant is, staying in the dark within a 24 hours period. So this actually related to one of the questions I got really often too, is like, if I use grow lights, how long should I leave my grow lights on, right? So how many hours of light are planted to receive actually varies a lot by species, right? Or by genus, right? So just like human, right? Some of us can function really well with 6 hours of sleep. Some of us need like at least 8 to 10 hours sleep. So plants are the same. So it really depends. And what more interesting too is plants actually require a different photo period in different stages of growth. So when I read that, one of the examples that immediately popped into my mind was from Doug from Vermont Hoya. So when I was reading his website, he was talking about Hoya calycina, which is the fussy leaves Hoya. I have one, but it's too far. Anyway, the Hoya calycina, right, I'm trying to post a picture somewhere. And this plant actually, in order for it to bloom, it's actually require a change of day length. So, in the nature, when it's, live in the wild, the change of the day length, in the summer versus in the winter actually trigger this particular species of Hoyas to form buds and bloom. So that's one of the really good examples of how photo period requirement can actually change, even within the same plants, just because, the plant it's actually in a different stages of growth, like vegetative growth versus flowering versus fruiting. So that's very interesting, right? However, I know that's very abstract. That's not useful, right? However, generally speaking, most of the horticulturists would agree that you would need to give your plants at least minimum 10 hours of light per day, per 24 hours, in order for the plant to survive. So that would be a good starting point. So you may want to adjust it or fine tune it, based on what your environment is and also what the plant is. So the next two factors are much easier to understand. So the third factors we're going to talk about is how far the light is from your plants, right? So this is pretty straightforward. So if this is a plant and if this is the light source, right? So the closer the light source is for your plant, the more concentrated the photons will rain down in that particular area, which means that the lights will be more intense. On the other hand, if your light source is a lot farther from your plants, then the photons, when the light beam come down, you may lose some of the photons, right? So it's just like when it's rain, if the rain cloud is so high up, some of the water may lose from like evaporation or whatnot, and at the end of the day, the rain that actually drop on the floor will be less, right? In comparison to when the rain cloud it's a lot closer to the ground. So same as the concept of photons. So the farther away the light source is from your plants, obviously the photons will be less concentrated. On the other hand, if it's closer to your lights, the photons will be much more concentrated. But bear in mind that the other thing that light also give out other than the photons is heat. So if you keep your lights too close to your plants, you will also have to consider that will there be like heat damage as well. Last but not least, right, the four factors to determine how intense, right, the light intensity is how big of an area your light source is actually covering. So if the area is bigger and you have one light source, so the photons will have to disperse to a bigger area, which means that each plant in that particular area will receive less photons. And if you have a smaller area that the same light source cover, right, it means that the photon is going to be more concentrated in that area, and those plants within that area will receive more photons per plant. So it's just as simple as that. All right, so we just cover the four factors on how to determine light intensity, aka the total volume of light. We talk about PPFD, right, which is the photosynthetic photons flux density, right? Basically, how concentrated the photons it's raining down in the units of UMO per square meter per second. And the second factor we talk about is photoperiod, how long the plant is actually receiving light within a 24 hours period. And then we all talk about like how far the light is from the plant And last but not least is how big of an area the light is covering. So this is a very important concept, especially when we go into next week or next video about grow lights, because when we determine if a particular grow light is enough, enough to drive the plants to grow, we have to look at all this stuff. We cannot just look at, how long I leave the lights on, or how strong the light is, or like how many plants the light is actually covering. We have to look at all that stuff. And that's why at the beginning of the video, I said that it is very important for us to understand all this basic scientific concept in order for us to move on. So I hope, this is okay enough to understand. Just make sure you leave, if you have any question at all, just leave it in the comment below. I'll do my best to answer. I am not a horticulturist or botanist, but I'll do my best to answer. Alright, so now that we get through all the equation stuff, the science stuff, let's talk about natural light, right? That we can get from our home without any supplemental lighting. So some of us are blessed with big windows in different directions of our home, and we get some good, natural lights for the plants. Right? So we're gonna talk about the lights, the different light that we get from each directions because they are different, and also maybe what type of plants may do well in those directions, right? So first of all, you have to have a compass or like a compass app on your phone to measure the directions, right? Because I don't know about you, but I wouldn't know what directions my window is facing until I actually take a compass out. Like my sense of direction is not good. I don't know how I get through life without Google Maps from before. But anyway, either you have an actual compass or you have a compass app on your phone. You can very easily find out what directions your window is actually facing, right? So we're gonna talk about each direction. So first direction we're gonna talk about is the east. East is actually a great directions for most of the house plants. If you have an east window, congratulations, it's awesome, right? So the east lights, when you think about it, when the sun just started to come out, from the east side, right? It's very gentle. It's at a lower angle. It's at a lower angle. It's very, soft. So it's actually good for a lot of the house plants, including Hoyas, philodendron, monstera. It's actually, really suitable for those plants because those are bright lights, but they are not too warm or too hot. Imagine all this house plant that we have, like again, monstera, Hoyas, philodendron, peperomia, I don't know. Most of them are understory plants. They're like, live under the canopy. So they do want light, but they don't want like blasting, hot sun on them. And that's why the east light is always really great, for most of the Hoyas and the Aroys. So I think if you have a big east, unobstructed east window, you should be able to grow a lot of nice plants. All right, next we're gonna talk about south, right? So south is different. So imagine, right, we talk about the east light, it's the sun go from the, east side, and then it will eventually move up on top of our head, which is, when the afternoon approaches. And the south light, it's actually the hottest, most intense light out of all directions. So I would say, succulents and cactus would do really well in this direction. So I do have a south-facing window, as you can see. Today is a pretty overcast day, so you don't see a lot of light. But I do have my succulent outside, and my succulent is just so happy living, facing a south-facing directions because they are like growing, they're like turning this really beautiful, red or orange color because of the sun. So yeah, so I would say like the south sun, it's like really suitable for succulent and cactus. Basically, plant that require a lot of sun in order to thrive. So that's pretty much it. On the contrary, you will have to pay attention if you have a really bright south window. You probably don't, or south patio, you don't want to like put like, the more like foliage or thinner leaf species outside. So I try to put philodendron hederaceum outside, which is the hardleaf philodendron. It's dried out in like 2 days. I didn't know what I was thinking. I didn't know why I did that. And I also try to put a Hoya Canosa Crimson Queen outside, which is more succulent. Still, it's too much light for it. So I do that as experiments. So I know that, you know, those plants is probably not too tolerant with the south sun. So next we're going to talk about the west. So the west, similar to the east, the sun also comes in from like a lower angle. However, the western is actually hotter. The temperature of the light, you know, it's hotter than the eastern. So how you could still put some foliage plants on your west window, but I would actually observe the plants, how it's do, because some of us get more western, right? If you have like an obstruct window, you may get more western than other people. And then you also want to maybe, instead of like having your foliage plant, like the thin leaf species, right up your west window, you may want to like pull it out like, you know, a foot or so, you know, just so it doesn't really get that blasting like hot western as well. So yeah, so I would say like, you know, western is definitely not as intense as the south sun. It may be a little bit more intense than the eastern just because it's a little bit hotter. Last but not least, loft. So unfortunately, if you only have loft window, you may not have a lot of options to put plants there because the the loft never get any sun. That's what I meant. It's never get any light. So if you must, you could try to put some low light tolerance plants there, such as, I don't know, CZ plants or snake plants, right? However, like, bear in mind that low light tolerance plants doesn't mean that they like the low light condition. Zero plants on the planets of Earth are like low light condition. All of them thrive on certain level of light, right? Because remember, it's food for them, right? So yeah, you can probably try to put some like CZ plants or snake plant, the low light tolerance plants, you know, at your loft window if you must, but eventually they're gonna die. So you may want to consider, I don't know, moving them somewhere else, not have them, or basically just add some supplemental lighting, artificial lighting, which we'll go over in our next video. But yeah, all in all, loft side doesn't get a lot of light. So you will have to supplement with grow lights if you do want to put some plants at your loft. So one really important reminder when we look at lateral lights in our home too is, yes, you may have east, south, or west or loft facing window, right? However, is there anything blocking your window, for example? Like, is there another building blocking your window? You know, right next to you is your patio like cover. So those are the stuff you also have to consider when you think about how intense your light is, you know, with lateral light. So for example, yes, I do have a south window, but I also do have a building about, I don't know, like 20 feet away from me. I'm really bad at distance. So for me, it means that I may not actually get the full south sun, right? And also like, you know, it's your patio cover, for example. So I actually talked to like one of the Hoya growers from Thailand. I purchase from him really often, and he told me that you know, his greenhouse not greenhouse, but he's like a nursery in Thailand, because of how much sun they're getting all the time. In order to successfully grow Hoya, he actually have to put like something called a shade cloth, you know, if you guys know that. So to cover up, you know, the nursery so the Hoya doesn't get burned. So those are the stuff that you have to consider, right? So if your patio is shaded, you know, you may get less density of light or less intensity of light. If you have a building next to you, you know, you may get like also less intensity of light. Or even like if your shelf, you know, you put next to the window, it's a couple feet away from your window, then you may get less density of light. So those are the stuff that you also have to consider when you look at lateral lights, you know, within the different directions of the windows that you put your plants in. All right, so if you guys stay to the end of this video, thank you so much, because I know this is like a heavier video because we are throwing a lot of you know, scientific terminology and math and all that stuff at you. But those are the really important concepts for us to understand if we want to truly know how to utilize light effectively to maximize our plant's growth. So for the next video, we're going to go into artificial lighting, or, you know, aka grow lights. We're going to learn how to supplement or even substitute natural lights with artificial lighting, because some of us just don't have enough natural light in our home, right? We're going to go into like other terminology like Kelvin, you know, which measure the light temperature, and what does this actually mean when you see that on the box of the grow lights. And also watt, right? Does watt mean anything actually, you know, to plants? We're gonna do a lot of math conversion of how to convert, you know, the rather useless like measurements such as lux or lumen or foot candle into the more useful measurements of photons, because that's basically how plants see light instead of like how humans see light, right? And last but not least, next video, I'm also going to give you some recommendations of the grow lights I use. So I'm a hobbyist grower, so my recommendation will mainly be iridescent light or LED light. So yeah, so if you are looking for more like professional stuff, you may need to, you know, go to someone else. So as always, thank you so much for watching. Please click like if you like this video. If you want more future video like this, make sure you subscribe. So one of my goals to film all this video is I make it educational. So I want you guys, after you spend all this time to watch the video, I want you guys to walk away with something, right? So that's basically my goal. So leave it in the comment below if you have any recommendations, if you have any you know, any thoughts, you know, you want to share with me. I would love to hear them. And as always, I'll see you next time. Bye.